Okay, today we're going to be starting our fourth marking period. Normally after electricity we'd study magnetism, but I felt that was just too difficult to do from a remote location. So we're going to switch over to our next unit, which deals with waves and oscillations and sound and light. And what we'd like to work on today is our very first lesson for oscillations, and that's the oscillation of something like a pendulum. And your purpose today in this little mini lab is to investigate the factors that affect the time it takes a pendulum to oscillate. Okay, so I want to start with some tips. Make sure your string is at 0-degree angle when you measure it. So if you hold the string steady, you want to measure the length from the time when it's at 0. You want to make sure you measure to the middle of the ball. You want to make sure your PocketLab is centered with the ball. So if you had your PocketLab, you'd make sure it's centered and then you just pull it back a little bit. On the picture to the left, the length is about 55 centimeters. So again, you go to the middle of the ball. You mark off where that is, and it's somewhere between the 50 and the 60, hopefully right in the middle, so I called that 55. Again, here's your PocketLab, there's the ball, it's hanging from the ceiling. Okay, next tip. What you're going to do is you're going to be working with the terms period and frequency. And period is the time it takes for one full cycle measured in seconds. So if you watch, that's one period. One full cycle. Forward, backward. And you time that, and that time would be called the period. You'll be looking at the time for multiple cycles and dividing by the number of cycles to give you a better result. So you'd never want to just time one cycle. It's going to be way too inaccurate. So the more cycles you time, the better. The other term you need to know is frequency. Frequency tells you how many cycles there are in 1 second. And again, you'd never just time 1 second. You'd do many more seconds and then set up a ratio and figure out how many cycles there are per second. That's going to be measured in a unit called hertz, and that's going to be a very important unit in this unit. Okay? So you count lots of cycles and divide by the time it takes to make that many cycles. So frequency, number of cycles, over time, period, time for one cycle, and that's in seconds, and this is in hertz. Okay, so I'd like you to make a hypothesis before you start this lab. How do you think each of the factors will affect the time it takes the pendulum to swing once? What are we going to change? We're going to change the mass of the ball. We're going to change the length of the string. We're going to change the angle that we pull it back to, and we're going to change the gravity on the planet where the pendulum is swinging. So think about each one. Just tell me something like a bigger angle will make a longer time, a shorter time, or it will not affect the time. So for each of these, simply tell whether or not you think this factor will cause the time to increase or decrease or stay the same. Okay, you're going to be using a virtual program to do this. Unfortunately, we're not going to be here at school, so we can't actually do this live. I would love to have you try this live, but this is the next best thing. So click on the link where it says the program is found here. Click on the thing that says angle degrees, that's right here. When you click on that, that will set the angle to 0, so it hangs straight down so that you could measure the length. If you click that same spot again, it will restore the angle to what it was before. If you want to literally change the angle, use the arrows to make it bigger or smaller. Okay, click on the ball, not when it's hanging straight down, but when it's displaced, and that will make the ball start to swing. Anytime after it starts to swing, you click on the PocketLab, boom, and it will start collecting your data. The data will show up below the window that has the actual action. Okay, if you don't like the way your data looks, you click on the PocketLab again and it will start collecting your data again. To reset the system, you have to click on the ball. And the ball's in constant motion, so it might be a little tricky to click on it, but do your best. Time it so that you click on the ball. Okay, this is what it would look like if we were doing it live. Unfortunately, that is not a thing. Okay, so the first part of the lab, you're going to hold the all the variables constant except for angle. You're going to see how does changing the angle affect the time it takes to swing. Make sure you record the length, the gravity field, and the mass, because those things will not change. And then do 5 different angles, and whatever angles you happen to pick, measure the time it takes to swing once. How are you going to get the time it takes to swing once? Well, let me come back here to our picture. And the way you get your time to swing once is find the spot on the graph that's convenient. Count 1, 2, 3, 4, or however many you can, oscillations. Remember the first one is 0. And then see how much time it took to swing 4 times. Let's say that it took 6.8 seconds to swing 4 times. So you divide that, and that will tell you the period, the time to swing once. If that's not clear, please contact me, and I'll go through it with you and make sure you do it correctly. Again, you look at the graph below your action. You pick a spot to start. Wherever it started at 0 is probably the best. Count off your oscillations, remembering the starting point is 0, and then it's 1, 2, 3, and 4, and then get the time. So how much time did it take to do a given number of oscillations? And again, you divide, and that value you get is called the period, and that's what goes into your chart. Okay, when you're done, make a graph. You're going to put angle on the X, that's what you were in charge of. And you're going to put the period on the Y. The symbol for period, if you wanted to use just one letter, is a capital T. Don't use P, that's pressure and power. Capital T is what we use for period. And again, it's in seconds. In part 2, you're dealing with length. So this time, keep the angle, the gravity, and the mass constant. Make sure you write down what those values are. Do 5 different lengths, and then plot out your graph. Again, length would be on the X, and period would be on the Y. Don't forget your titles and all the other things. Part 3, you're going to change the mass of the ball. Part 4, you're going to change the gravitational field of the ball. As always, write down your constants, put the thing that we change on the X, period goes on the Y. And the end, tell what factors had an effect on the pendulum's oscillation and which did not. For the factors that actually mattered, tell how each of them affected the period, and tell me whether or not your hypothesis was accurate. You're not going to get extra credit. You're not going to get deducted credit if your hypothesis is wrong. So just do your best with that. Again, I wish we could be doing this lab live, but unfortunately circumstances prevent us from doing that. So do your best with the virtual version, and then I will talk to you again tomorrow. Okay, have a great night.